Welcome to this training on Nile's overview and architecture. Traditional networking is complex. VLAN sprawl, manual configurations, and constant maintenance create inefficiencies and operational overhead. Nile takes a completely different approach, redefining how networks are built and consumed. In this session, we'll cover what Nile delivers today as part of its access service, how traditional networking relies on VLANs and manual operations, how Nile eliminates complexity with a modern, scalable, and fully automated architecture, paving the way for the future of connectivity. By the end, you'll see how Nile is transforming campus networks by making them simple, secure, and service-driven. Nile delivers a complete cloud-managed unified wired and wireless fabric, redefining campus networking with a fully integrated, service-driven approach. As part of Nile Access Service, we handle wireless and switching infrastructure, covering design, installation, and ongoing operations. Unlike traditional solutions, Nile developed its own hardware and software from the ground up, ensuring a seamless, optimized system built for simplicity, scalability, and reliability. Our architecture is designed to be extremely simple. We use a modular Lego-like design called Nile Service Blocks, allowing networks to scale and deploy effortlessly. This ensures IT teams spend less time on integration and troubleshooting. Nile also delivers guaranteed performance. Our advanced tier deployments come with monthly SLAs covering availability, capacity, and coverage. If these metrics are not met, customers receive credit-backed guarantees, ensuring a reliable and measurable experience. Security is built in, not optional. With our Campus Zero Trust approach, we enforce zero unauthorized access, identity-based authentication, tamper-resistant hardware, and mutual authentication as part of Nile's Zero Trust Foundation by design. And finally, Nile operates on a pay-for-use model. Instead of large upfront capital investments, customers only pay for what they use, ensuring a cost-effective and scalable deployment that adapts to real-world network demands. In this module, the focus is on understanding how Nile's wired and wireless services, combined with its innovative architecture, address the challenges of modern campus networks. In the next sections, we'll dive deeper into the individual components of the architecture, such as gateways, active-active designs, redundancy, and scalability. Let's start by understanding how traditional network deployments work and why they are so complex, followed by how Nile revolutionizes and simplifies the entire process. Traditional network deployments are complex, fragmented, and error-prone. Let's break this down into two major challenges. Product selection. IT teams must sift through dozens of SKUs, selecting product categories, models, and accessories for every component: Wi-Fi access points, switches, distribution layers, and more. This process is time-consuming and prone to errors, with compatibility and capacity planning adding further complexity. Manual configuration. Once hardware is procured, manual device-level configurations take over. VLANs, IP addresses, routing, and port-level settings must all be configured by hand. This introduces human error risks, leading to misconfigurations, outages, and increased operational overhead. Ongoing tasks like validation, upgrades, monitoring, and troubleshooting only add to the workload. Now let's see how Nile eliminates this complexity. End-to-end solution. All design, installation, and operations are handled by Nile, removing the need for manual product selection and SKU management. Automation over manual effort. Device and port configurations are automated, ensuring error-free deployments and seamless operations. Simple pricing. Pricing is based on per user or per square foot, with clear and flexible billing options. No SKU-level calculations required. Professional services. Delivered via partners with automated tools, ensuring fast, accurate deployments. Scalability made easy. Add-ons like Nile extensions are offered with straightforward per-device pricing. By collapsing 20-plus steps into a single process, Nile transforms networking from a burdensome task into a streamlined experience. This means no manual configuration, no SKU juggling, and no human errors, just a network that works effortlessly. Nile is not just simplifying networks, it's redefining how they are consumed. Let's take a closer look at how traditional VLANs compare to Nile's Layer 3 architecture, and why Nile's approach fundamentally changes the way networks are designed and operated. In traditional VLAN-based networks, segmentation is confined to broadcast domains. This design not only limits scalability, but also introduces unnecessary overhead as the network grows. Nile's Layer 3 network eliminates the concept of broadcast domains entirely. Instead, it uses host-based segmentation, ensuring each device is securely isolated and operates within its own unique segment. Communication between VLANs requires external routers, which adds complexity, increases latency, and introduces additional hardware dependencies. Nile solves this with built-in inter- and intra-segment routing, enabling seamless communication without external devices while improving performance and simplifying network design. In VLAN-based networks, configuration is a highly manual and error-prone process. Device-level and port-level setups, such as VLAN assignments and routing rules, increase the risk of misconfigurations, leading to downtime or security vulnerabilities. Nile removes manual configuration entirely through zero-touch automation, drastically reducing operational overhead and ensuring consistency across the network. VLANs also offer limited isolation, leaving networks vulnerable to lateral movement and port-level attacks. Nile embeds zero-trust principles into the architecture with features like identity-based authentication, mutual authentication, and granular access controls, ensuring no unauthorized access to the network. Redundancy in VLANs relies on spanning tree protocols, which are cumbersome, prone to loops, and create instability. Nile leverages OSPF, Open Shortest Path First, to provide seamless redundancy with optimized path selection, ensuring stable and efficient network operations without the complexity of spanning tree protocols. Broadcast storms, a common problem in VLANs, can disrupt network performance and reliability. With Nile's Layer 3 network, broadcasts are completely blocked, creating a stable, predictable, and efficient network environment. Finally, VLANs tie connectivity to physical locations, making networks rigid and unable to adapt to changing requirements. Nile's policy-based dynamic connectivity allows networks to adapt in real time, providing flexibility and agility to meet modern demands. As you can see, Nile's Layer 3 architecture not only solves the inherent challenges of VLANs, but also sets a new standard for how networks should operate: secure, scalable, and automated. This approach forms the foundation for a simpler, more modern network that eliminates decades of complexity. Let's take a deep dive into Nile's architecture and understand how it delivers redundancy, automation, and high performance at every layer. At the foundation of the Nile's unified fabric are the Nile gateways, which provide seamless connectivity between the customer's network and Nile's architecture. These gateways establish a Layer 3 point-to-point connection with the customer's router or firewall, simplifying integration and eliminating VLAN complexities. Unlike traditional architectures, both Nile gateways operate in active-active mode, ensuring continuous availability, load balancing, and seamless failover. For traffic routing, Nile supports OSPF preferred, as well as static routes with equal cost multipath (ECMP), providing optimal path selection, redundancy, and scalability. These gateways can handle uplink speeds ranging from 1G to 10G, with options for 40G in larger deployments, ensuring scalability as network demands grow. The Nile gateways don't just connect to the customer's network, they also connect to the Nile headends, which act as the controller or brain of the Nile Service Block NSB. In this diagram, the headends are virtual, meaning they run directly on the Nile gateways instead of requiring separate physical appliances. This approach is efficient and reduces the need for additional hardware. For larger deployments, dedicated physical headends can be deployed as needed. As part of the architecture, customers can integrate their existing Radius servers for authentication. These servers typically connect to the upstream of the Nile network, providing flexibility and compatibility with existing infrastructure. Similarly, Nile supports DHCP servers, acting as a DHCP relay to pass requests between clients and the server. Additionally, Nile offers its own cloud-based DHCP server, which is part of a premium service offering. We'll cover more on this feature in a later module. Moving down to the access layer, redundancy is a core design principle. Nile switches are connected in a ring topology using high-throughput direct attached copper DAC cables. Each switch is also connected to both distribution switches, ensuring complete redundancy. If any single link or switch fails, traffic is automatically rerouted, maintaining seamless connectivity. Wireless redundancy is another key feature. Nile uses AI automation to translate the Ekahau file into a highly resilient salt and pepper network design, ensuring neighboring APs connect to separate switches. For example, in a deployment with 20 APs, 10 would connect to switch 1 and 10 to switch 2. If one switch fails, the APs connected to the other switch will continue to provide coverage, ensuring uninterrupted wireless service. To ensure the network consistently meets its promised SLAs, Nile deploys Nile sensors. These are small, wall-pluggable Wi-Fi devices that monitor availability, capacity, and coverage in real time. They continuously assess the health of the network and ensure performance aligns with SLA commitments. In addition to physical sensors, the third radio of an access point can function as a virtual sensor, reducing hardware requirements while maintaining monitoring capabilities. With redundancy at every layer, the NSB is engineered for continuous operation, maintaining full control path and data path functionality even during internet or cloud outages. Layer 2 networks have long been plagued by complexity, spanning tree loops, VLAN sprawl, and operational inefficiencies. Traditional solutions like spanning tree protocol attempt to manage these issues but introduce additional overhead. Nile takes a fundamentally different approach with a zero-trust layer 3 foundation. By eliminating VLANs, spanning tree, and stacking, we remove the risks of loops and inefficiencies altogether. We've reimagined how traffic flows in the network. Just as wireless access points send all traffic to a controller, Nile's wired ports create a tunnel, sending all traffic to the head end for centralized policy enforcement. This eliminates the need for VLANs and trunks, providing a fully streamlined, out-of-the-box solution without requiring external network access control or manual configurations. Traditional VLANs were originally designed to control broadcast storms, but have since evolved into a tool for segmentation. Nile simplifies this with a Layer 3 approach we call segments. Each segment maps directly to a subnet, enabling seamless segmentation of users and devices without VLAN complexity. While Nile eliminates Layer 2 challenges in the core network, we understand that end-user devices still rely on broadcast and multicast services. That's why we've automated these processes. Proxy ARP prevents unnecessary network flooding. IP Helper ensures DHCP broadcasts reach the right DHCP server. MDNS discovery is automated based on location, enabling seamless service detection. Multicast traffic is intelligently routed with auto-learning and IGMP snooping to optimize performance. Beyond simplifying the network, Nile enhances application performance. Automated quality of service ensures critical applications get prioritized, and traffic is tagged for end-to-end QoS enforcement by upstream routers. With this innovative Layer 3 approach, Nile eliminates traditional networking bottlenecks, removes manual configurations, and delivers a scalable, secure, and fully automated network experience. Nile is the only vendor offering true out-of-the-box zero trust for campus networks. The NSB is completely locked down, requiring authentication between every Nile element and with the Nile cloud. This is secured through embedded TLS certificates and TPMs. All traffic within the NSB is encrypted with zero-config MACsec, and traditional access methods like SSH, Telnet, and console ports are eliminated. Nile operates on a strict zero-trust model. Every device must authenticate before accessing the network. For wired connections, we implement parallel 802.1x and MAC authentication, ensuring robust security and broad compatibility. Imagine the simplicity of securely onboarding wired docking stations without IT involvement. Employees simply connect, are redirected to their identity provider for SSO, and gain immediate network access. SCIM integration provides immediate access control. A disabled user in your IDP loses network access without delay, ensuring swift and efficient security enforcement. We've integrated SSO, Radius, and advanced fingerprinting directly into our platform, providing effortless and secure authentication for all devices wired or wireless, user, IT, or OT. Nile delivers built-in zero-trust isolation across both wired and wireless networks. By default, lateral communication between devices is blocked, effectively halting malware spread at Layer 2. Traffic is then directed to your firewall for policy enforcement, or policies can be defined directly within the Nile Service Block NSB using our trust service and microsegmentation. Uniquely, Nile provides this robust isolation without requiring any configuration. Nile delivers truly universal zero trust by integrating with cloud Zetanas solutions like Zscaler and Prisma. You can easily define policies to route employee traffic to the closest Zscaler pube. We've eliminated the complexity of tunnel configuration. Nile automatically establishes secure tunnels to the nearest POP for every site, ensuring efficient routing for all locations. Regardless of network size, from small deployments to massive installations with thousands of APs, Nile's NSB setup is consistently simple. We only require uplink IPs and a subnet for Nile elements. The NSB's autonomous design allows it to run a local DHCP server, automatically assigning IPs to our switches and APs for initial bringup. These essential parameters are pushed via Bluetooth to the edge switches connected to your router. The remaining switches? Just a simple beep and scan, no configuration needed. Unlike zero-touch provisioning from other vendors, Nile offers true zero configuration and instant network activation without the need of any manual intervention. That brings us to the end of the session on Nile's architecture. We've explored how Nile is redefining networking with a simpler, scalable, and secure approach, eliminating VLAN complexities, embedding zero-trust security, and enabling fast, automated deployments through Nile Nav. With Nile, networking is no longer about managing infrastructure. It's about consuming a reliable, self-operating service that adapts to modern needs. Thank you for your time.